Good morning. It's Tuesday. We're going to talk about inequalities today. So inequalities really are just equations, but you remember when you're in elementary school and you learned about the alligator mouth, right? Pointing towards whichever number was bigger. So -1 is less than 5, right? Remember the less than and greater than symbols. Less than or equal to, greater than or equal to. These are inequalities. Well, once we get to algebra, we can solve inequalities that are like equations, okay? So written out like equations with a variable, only instead of an equal sign in the middle, we have an inequality symbol. All right, so let's take a look at that. First of all, let's take a look at graphing inequalities on a number line. So it's very simple. If I have x is less than 3, then I can graph this on a number line. Now, if it's a less than symbol without the greater than or without the equals to, then we're going to actually put a little hole here. On graphs in algebra, when we put a little hole in a graph, it means not that specific number, but everything around it or everything below it or above it. So this means all numbers less than 3 are all numbers that are infinitesimally less than 3, but not 3 itself, okay? If we have x is greater than or equal to -1, then we're going to actually include -1 because -1 is x could be equal to -1. So we're going to include -1 here and then all values greater than that, all right? So one of your pages today is to take a look at that, just graphing inequalities on a number line. I've done a couple of examples and then looking at a graph. So I should be able to look at this graph, see that this is filled in, and so that this is and it's greater than, so this is a greater than or equal to -1 equation. If I had to write inequality, if I have to write that, then I can choose any variable. F is greater than or equal to -1. Z is greater than or equal to -1, okay? You can even choose Greek letters. Theta is greater than or equal to -1. Get creative, that's fine. Okay, so let's take a look at solving inequalities like we're solving equations. In fact, the equations work we just did, you could put an inequality symbol into each one of those and solve it. There's just one part that's different when we're solving inequalities. So we're going to start with really simple ones today, and we'll do more complex ones tomorrow, like the equations y'all know how to solve, okay? So let's look at this example. -3 is greater than x plus 1. Okay, so we're trying to find out what are all the possible values of x. Could I plug in a 5 for x? Could I plug in a -2 for x? Could I plug in 100? -100, all right? And that's what this final answer will tell me. So just like an equation, I'm going to subtract 1 from both sides so I can isolate the x or get that x alone on one side. All right, so I subtract 1, -1, -1. These ones here cancel, right? -3 minus 1 is -4. And so we find out that I have this kind of backwards from the way I would say it. -4 is greater than x. So I like to flip that around, right? And so, of course, whichever way this is pointing to whatever one it's pointing, it needs to continue to point in that direction. It was pointing at the x. This is, if I read this backwards, x is less than -4, or -4 is greater than x. And so x is less than -4 is how I would write my answer, because that's how I would say it. Now, could I plug in 10 for x? No, because x is less than -4. Could I plug in -5? Yes, because -5 is less than -4. Okay, so let's check this out. The primary rule that we all have to remember when we're solving inequalities is if we multiply or divide by a negative number, we flip the inequality. And if we were in class, I would say times -1, and you'd flip. Times -3, flip. Divide by -8, flip. And we'd all do this and it would be crazy and fun. But we can't. So do that. Make your family do it, right? Line people up 6 feet apart, of course. Make your whole neighborhood do it 20 feet apart, of course. make them say times -3, and then make them flip to the other side. Divide by -1/8, flip to the other side, okay? So this is important. This is the most important part, of course, of your assignment for the day. Let's look at an example. I have -5a is less than or equal to 9. Okay, we know how to solve this if it's an equal sign, right? Divide by -5, divide by -5. So I showed this, divide by -5, divide by -5. These -5s cancel each other, right? -5 divided by -5 is 1. And then 9 divided by -5 is -9/5. Because I divided by a negative, I'm going to flip the inequality. Again, if we were in class, we would have experimented with this. We would have found out that when you multiply by a positive, you can stick in the same numbers that you could in the beginning, right? But so like -5 times 1 is less than or equal to 9. That is true. But if I brought this down and didn't flip this, plugging in 1 would no longer work. We would have to plug in -1. So we start finding out that this multiply and divide by a negative, flip the inequality symbol, is always necessary to maintain the number sense of it, okay? Let's do this one together. I've got -7/5 x is greater than 1/10. Now, this is something we've done where we've looked at if I have a fraction times my variable, that I'm going to multiply by its reciprocal. That's right. So I'm actually, I want the negative to go away. I want x alone, right? So I'm going to multiply this by -5/7. What I do on one side, I do on the other. So by -5/7. Okay, can everybody see that? So these here, right, if I reduce before I multiply, negative times a negative is a positive. The 5s reduce with each other. The 7s reduce with each other. I'm down to what I'm hoping for, which is 1x, right? So on this side, I just have plain old x. Let's take a look at this other side here of the equation. I'm going to reduce before I multiply. So I'm going to reduce this 5 and this 10. And I'm going to come out with a 2 down there, right? A 1 up there. So on this side, it looks like I've got a positive times a negative is a negative number. So let's remember that, right? So I've got -1 in the numerator and 14 in the denominator. But what did I do? I had to multiply by a negative. So what do you do when you multiply by a negative? Flip to the other side. Okay, so I have a greater than symbol. Now it needs to be less than. Put a box around your answer. If I needed to graph this, then I would draw myself a number line, put on a 0, put on a 1, a -1, sorry, negative, stick in a -1/4. Let's do that really fast. I would just do this. Put in arrows going in both directions. I'd put in a 0. I'd put in a -1, leaving a bunch of space. And this is -1/14, which is somewhere crazy in here, -1/14. Greater than, which is an open circle, going to the right. Okay? Okay. So I hope this is helpful. Inequalities is pretty neat. We would have explored this together a lot instead of me just teaching it. So I'm sorry about that. Yeah, we'll keep doing this for a couple days. I hope you all have a great day. Bye.